I'm Dr. Faith Kreitzer, Food Safety Extension Specialist at the University of Tennessee, and I've been involved in a research project with my colleagues at UT, as well as our partners at North Carolina State University, evaluating novel sanitizers for use in organic production. This project, funded by the USDA, has evaluated these novel sanitizers, specifically 3 essential oils, for their use in organic production in post-harvest wash systems to inactivate pathogens on produce. An essential oil is a natural oil extracted from a plant. There are essential oil products already approved and in use by organic growers for pest control, fungicides, and herbicides. In our research, we are looking at essential oil use as a sanitizer to minimize the risk of spreading foodborne pathogens in the wash water. Our research evaluated cinnamon oil, clovebud oil, and thyme oil. Since oil and water would naturally separate, we created an emulsion with each oil that allowed it to disperse into water. We used gum arabic, whey, protein, and lecithin to surround the oil droplets, allowing them to disperse into water. The crops we evaluated were tomatoes, spinach, peppers, romaine lettuce, cantaloupe, and carrots. We tested our emulsified essential oil solutions by intentionally introducing bacterial foodborne pathogens onto the surface of produce, then immersing this contaminated produce in a mock duct tank containing our trial sanitizer. The pathogens used included Salmonella, E. coli 0157H7, and Listeria monocytogenes. For comparison, we also ran the trial in water that contained no sanitizer and a water solution containing chlorine, a commonly used sanitizer. During this process, bacteria from the contaminated fruit would fall into the water. We would then take uncontaminated produce and pass it through the potentially contaminated water. To evaluate the effectiveness of our essential oil-based sanitizers, we then tested both the water and the uncontaminated produce that passed through the water for the presence of pathogens. Organic matter accumulation can also cause chlorine to be less effective. For comparison, another trial parameter was the inclusion or absence of organic matter in the wash water. For all product types except leafy greens, which included romaine lettuce and spinach, our novel sanitizers performed as well as chlorine at limiting the cross-contamination onto uncontaminated produce. In many instances, our systems performed better than chlorine when organic matter was added to the wash water. This is a very promising first step, but there's still more work to come. We are in the process of conducting more in-depth evaluation of our novel sanitizers to evaluate the impact of post-harvest product quality and sensory impacts. It takes all of these pieces coming together in order to lay the foundation for future work if these types of sanitizers are to be commercialized. So you may be asking yourself, can I make my own sanitizers using your recipes? And unfortunately, the answer is no. Every sanitizer has to be approved by the EPA for efficacy and also in organic production by the NOP. We hope that this research does pave the way, however, to future commercialization of these novel sanitizers, and that one day in the future, organic producers will be able to use them in their operations.